Hi guys, welcome back to my channel, and in this video I will teach you how to use a stepper motor to charge your phones. Now the property of a stepper motor is its rotor that has a large number of teeth, so it can produce high voltage at a very low RPM. And remember that the generated voltage by the stepper motor is always AC. So for that reason I will have to use a bridge rectifier, a 32 amperes. You can also use a smaller one because I'm obviously not going to generate 32 amperes. Yeah, you can use a simple 2 ampere or 1 ampere rectifier. That is enough to start your cell phone charging. Okay, so now I'm going to generate electricity with the help of this stepper motor and measure the voltage with the help of this multimeter. So the pointer is to 200 volts AC. Okay, so guys, as you can see, I have done the connections. This pink and this wire has been connected to the multimeter terminals, and this one is the tapping point, which will not be connected to the multimeter. It will stay open, and this joint is for connecting the two built-in windings. Okay, so now we'll rotate the shaft and you should see it reflect some voltage. You can see that such a low RPM, it is generating 3.5, 4.4, 4.1, 6.9, 8.8 volts with simple finger rotation. Okay, so obviously I can generate a good amount of current and voltage with the help of this stepper motor, and it should be enough to charge your cell phones. And one most important thing is that it is brushless and there is no gearbox attached to it. So that was the voltage test. Now what I'll do is I will connect this rectifier. Since it is producing AC at the moment, I will convert this AC to DC. Yeah, you see this plus, you see this plus terminal. This indicates that this terminal is positive, and the terminal opposite, vertically opposite to it, is the negative. Okay, so positive to the positive, and negative to the negative. Oh sorry, the output from this stepper motor is AC, so there is also the sign of AC. So AC wire is this one and vertically opposite is this, so AC wires will be connected over here. Okay, and this one, AC wires have been connected. Now all I have to do is connect a USB wire that will be directly connected to a mobile phone. Okay, so removing this. Okay, so I have connected the rectifier directly on to this stepper motor. Okay, now guys, this is the charging pin from a mobile charger. Okay, and these are the two wires. So as I said before, a red wire is always for the positive and the other one is automatically the negative or ground wire. So positive has been indicated over here, so a red wire will be connected to this terminal. Okay, so red wire has been successfully connected. Now the only wire left will be connected to the left open terminal on the rectifier. Now this is ready to charge your smartphone. Okay, so let me connect it first. Okay, so guys, I have placed this stepper motor and held it with this vise, and the crank is connected to the shaft. As you can see, this is the bridge rectifier that I connected, and there is no other wire given. You can see all the wires are here, and these two are the only wires that are coming out from the rectifier and going here directly to the mobile phone. Now when I will crank this in any direction, since it is generating AC which is then converted to DC, it should start charging. Okay, so let's do that.
Hi, in this video I will be using a permanent magnet BLDC motor as a powerful generator. Now this BLDC motor is 250 watts and is from an electric rickshaw. Now a BLDC motor has 3 terminals and you can see that this one has 2 cables. The thicker cables contains 3 wires that are for running the BLDC motor and the thinner cable is for controlling and sensing. Since the controlling cables are not needed when using this as a generator, so I'm going to remove them, but I will still leave a little bit wire just in case if I'm going to use this motor as a motor in the future. Now the BLDC motors containing ferrite magnet are easy to rotate, but these BLDC motors use neodymium magnets that have real strong magnetic locking, which makes them really difficult to rotate with hands. So if you are planning on using them as a generator, then you must consider this as a back factor. Also, the magnetic locking is so high that it is almost impossible to give it a spin with your fingers when compared to our usual permanent magnet brushed DC motors or brushless ferrite magnet BLDC motors. The armature windings of this BLDC motor are star connected and the generated output from a BLDC motor is always alternating. Now you can see that there are 3 wires, so it is 3-phase alternating current. Now I'm going to use a multimeter to measure the voltage across any 2 terminals of this BLDC motor, since all the 3 terminals will produce same voltage because of equal number of turns for their armature winding. Now the voltage rating of this BLDC motor is 48 volts. So for that reason I am going to choose any 2 terminals for checking the voltage. Also, the hand rotation voltage is going to be very low since the rated RPM of this BLDC motor is around 3000 for 48 volts. So the maximum voltage that I can achieve through hand rotation is just 3 volts AC. Now I'm going to use a plastic rope to rotate the shaft of this BLDC motor at a little higher RPM, and let's see how much voltage I can obtain. So you can see that the maximum voltage I achieved was 14.6 volts with the rope, and the voltage was open circuit, meaning negligible current. Now for calculating the current generated by this BLDC motor when used as a generator, I will have to use a bridge rectifier. Now since I don't have a 3-phase bridge rectifier, so I'm going to simply use a single phase bridge rectifier and then multiply that ampere with 3 for 3 phases. So for connecting the bridge rectifier to the BLDC motor, I will choose any 2 wires of the BLDC motor and connect them to the AC marked terminals on the bridge rectifier. This method is going to give me current for single phase. So the maximum hand rotation amp reading was 0.84 amperes, which is 840 milliamperes. Now I will conduct the same test with rope rotation. So you can see that the output current measurement gives an improved reading with the rope because it is easier to rotate the shaft this way. So the maximum current spike that I could achieve was 3.89 amperes, which is almost 4 amperes. Since it's just a roundabout calculation. Now let's do some tests with practical loads. Like this one is a 12 volts motorbike bulb that I'm going to use as a load for this BLDC generator. Now since this one is a resistive load, so I don't need to use a bridge rectifier, or even if I use it, it won't matter. You can see the bulb can glow brightly with this. Now here what I have is an incandescent 12 volts 55 watts bulb, but its glass is broken and still the filament is still connected between the terminals, so it will glow for some time until the filament gets oxidized and burns up. So I'm going to test it with this generator. So as you can see that the bulb is glowing brightly and there is smoke indicating that the filament is getting oxidized. Oxidation can be confirmed by a white coating on the terminals of the filament and terminals holding the filament. So guys, now I'm going to use a 12 volts to 120 volts transformer to step up the generated output voltage of the BLDC motor. Now the transformer is also the single phase transformer, so I'm going to connect any two terminals from the BLDC motor to the thick winding, which is the primary winding in this case of the transformer, and to the secondary winding, which is the high voltage winding 120 volt. I will be connecting a holder. Now you can see this is an LED bulb, 3 watts, and since the power rating of this bulb is really low, 3 watts, so I can easily light up with just simple hand rotation. Now for some better output, I'm going to use this thread to light up the bulb. You can see that the bulb is glowing much brighter and more continuous. Now I'm going to replace the LED bulb with a CFL. Now the CFL was 15 watts, but this is a 100 watt incandescent bulb. That is the final power output. So as you can see that the bulb is glowing but not as bright as when it is connected to our home socket, since the transformer is only 120 watts. So guys, this was about the load testing, and now I'm going to measure the total output voltage open circuit at the secondary terminals high voltage side of the transformer with the help of a multimeter. Okay, so as you can see that I have moved the pointer of the multimeter to 200 volts AC, and I have connected its terminals to the secondary winding of the transformer. Now the rope rotation test is ready, and guys, as you saw that the maximum voltage I could generate with rope rotation after connecting the transformer was 128.3 volts. So guys, that would be all about the video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe. Thank you.